guys, welcome back to the new video. Today I'll be doing code forces round 122, educational round 122, problem D. So basically I was doing this problem for the last 10 minutes, so I thought to make a video. So basically I have read this question and I have thought the logic a bit. So let me explain you what have I done till now. So as you can read here, the question says that you are given an array with all of the array's value as 1, and you have to make the array A to array B. You have to convert to array B, and then if you like, you have to convert in such a way that if array AI, if the ith element of first array is equal to bth element of is equal to the ith element of the B array, then you will get the ci amount of points. So for example, you are initially given an array like for example, you are given an array, say 1 1 1 1. All the numbers of array are initially 1, and you have to make this like the array B given is 1. You don't have to make, but suppose this is the array B, so, and this is the array C, like 2652 2652. So this is the cost, like this is the price which you will get. Like suppose if you want to convert 1 to 1, and the how will you convert it array A to array B is here you have been given that you have to select any index I, suppose this, and you have to add in this the existing element like AI. You have to add this floor of AI by X, and you can choose any X. Okay, there is no limitations on X. So suppose I have 1, so if I want to make this as 1, obviously it is already made, so so there will be no operations. It is so suppose I have to make this 1 to 2, then what I can do is that 1 plus AI plus AI, like 1, and I can choose X as also 1, so this will get converted to this. Similarly, these all can get converted. So the thing is, you just have to tell like you are given an K operation, and you have to tell like with using less than equal to K operation, how much maximum profit you can earn. So firstly I thought that we have to convert this into this or this into this, like then we have to select which among these are beneficial to take such that the profit is maximum. So the first step would be to not think of like how to select the elements such that we can maximize the profit. The first step I thought till now is that what we can do is that firstly we have to convert this into this, or this into this into this. So it would be beneficial if we can think of the a minimum number of operations which will be taken to convert the number from this to this, from the ith element of array A to ith element of array B. So firstly we have to calculate for every element, like how much operations, how much minimum operations, because obviously a minimum we will take minimum, because we do not have to use more than K operation. So more the minimum, more we can get more elements we can get, so more profit. So for this minimum, what we can do is that here as you can see that the range of BI is only 1000. So what we can do is that we can run a bfs from 1, and say suppose this is 1, and for every element of like from every number from 1 to 1000, we can get in how much the fastest way we can reach to that number. Like suppose from 1 we can go to 2, and from 2 we can go to 2 we can go to 2 plus 2 by 1 is 4, and we can go also to 2 plus 2 by 2 3. So and from here we can go to 8 and 6, and like similarly from here we can go to 6 and 4. But see here we are only reaching 4 in 2 operations, so we will not take this. So we will store it, like we will store the number of operation for 4 as 2. So we can run dfs for calculating this, there is no big issue. But the main problem is that we have to think how to make, like how to select after so suppose we have like suppose we have got the operation, say like for this say 0, like this operation is 1. So for every element we'll get the operation, like number of operation to make this to this. So now we are done with, like we have now the question reduces to, we have operations, say number of operations of each element. Then for we have to select the number of operation, we have to select among these which are beneficial, and we have to maximize the mm, this. So but what I like, so for people who are thinking the greedy approach, let me tell you, greedy will not work here. Because say if you want, if you think that you want to get you will sort this according to the profit, and you want to make the maximum profit first. But what if the the number of operation is also very big? What if you get too small, what if you merge too small profit, and these operations are also very small, then you can get greater profit by only less number of operations, right? So this is definitely not a greedy problem. So this is like uh, so the question is now, like there are, suppose this takes k1 amount of operation, this takes k2 amount of operation, and these are the profit of I suppose this profit is p1, or let's denote it as c1, because here c array is given. So k2 profit is say c2. So we have to convert this into this. Okay, so this is looking like a dp problem, definitely. Or basically this is like a knapsack problem. Like in knapsack what we do is that initially we are given in capacity, and and this you can consider it as a capacity of first bag, like capacity of first item. So and this is the profit of, so in the same exactly in knapsack what you do is that you have to maximize the profit, and you are given the capacity. So and total capacity given is this k. So you can either select this element, or pick it in and put it in your bag, or you can just reject it and move forward. So I think it will be easily done with knapsack. But the thing is, but I was having one doubt here, that why will knapsack uh, knapsack why knapsack will not work? Because this is 1e6. So the time complexity will be 1e3 into 1e6, which is 1e9. That this is the main thing which I was thinking of. So what we can do is that I think this is kind in knapsack 2. I think the uh, K is this big only, the capacity. Oh, what we can do? If this would have been 1e3, then we could have easily done it. But this is 1e6. So I was thinking whether we will use all the 1e6 operation or not. I mean, whether these 1e6 operation of are used or not. Can we reduce these operations? Like, I just want to know that. Mm, because uh, I'm thinking like, because these are only 1000, and from 1 to 1000, like if we want to go from 1 to 1000, then what is the maximum number of operation which you will perform in obtaining all the numbers from 1 to 1000? Like you will go to 2, then here you will go to 3 and 4, and then you will go to, from 3 you will go to 6, and 3 plus 3 by 2, 4. From here you will go to 8, and 4 plus 4 by 2, 6, and 4 plus 4 by 3, 5. So what you are doing is that double double double, so every time you are able to cover number between 2 की power, suppose this height is h, 2 की power h and 2 की power h plus 1. Like here you have covered till 2 की power 1, here you have covered numbers till 2 की power 2 power 2. Like you have obtained, like covered in the sense you have made numbers, you have got the steps, like two operations here, two operations for you have found out the operations to make 3 and 4, and here you have found out the operation for making numbers till 8. And then what about 7? Here you will get 7, 6 plus 6 by 6. So in one step you are able to, in one step you are able to get 2 की power you are able to move 2 की power h. So 2 की power h less than equal to, but there are some elements which you are not able to get, like this 7, 1 2 3 4 5 6 7, only 7 left. But maximum you can get till, maximum number always you will get. So I just need to find how many steps, how many operations are required maximum. That will be, obviously it will be less than 1000, like operations will be less than 1000. because as you can see in one operation, if you do if you add only in if you increment by 1, and obviously in every step it will get incremented by 1, it can get incremented. So is there any so these numbers we can get in log n steps, like the power of 2, definitely. And from there, how many numbers are there between 2 की power x plus 1 and 2 की power x? How can we power x 2 power x okay. Or else what I can do is that I will run a BFS and I will check what is the maximum operation required. But I have a gut feeling that it will not exceed 2 की power n less than 1000. So n is less than 2 10, n should be less than equal to 10. So I hope 10 or maybe like 20, I guess. Maximum in 20 operation we can cover all the cases, but I need to be sure about this, so I have to take. So suppose if we get all the suppose if the operations of every number is less than equal to 20, then 20 into 1000 is 2e4. So we have the k value will be around 2e4, and this is 1e3. Okay, so 1e7. So I think k value must be between, like, but must be less than 20, because otherwise we can't do this problem. I am pretty sure that the k value must be less than 20 or maybe less than 15. Let's try coding this. So yeah, I was trying this. I have taken the input and I was like about to write the BFS. So we have pushed 1 here, and while q dot empty. Okay, then what we have to push elements from 1 x will vary from 1 to 1 to n, right? Let vary let's make a loop. Oh, we have to make a pair because we have to store the operation also. So pair. So first will be storing the element, second will be storing the operation. So for int x equal to 1, x less than equal to the current element, like we have to just wait, we have to push. Okay, we can't. Let's pair equal to 1, push this here, and 0 operation. Okay, let's int num equal to q dot front, q dot front dot first, right? And int operation equal to q dot front dot second. So this is how it is. So it will vary till num x plus plus, and then let me just q dot pop, and we have to again push back here, push here, q dot push. What do we have to push? New number, which is nothing but int, let's say new num, or else let's write that this has let's name it as z, or else new num, n num means new num. Let new number be old number plus num by x, right? So we have to push. Firstly we have to make this pair. We can directly push, but I don't know why in my VS Code I can't push directly, so I have to make pair first and then push. So the first number will be definitely new num, and the second number will definitely be a operation plus 1, right? And then let's push p here, and I hope it's fine. We have to define some p1 because already p is defined outside. I think it's fine. And one more thing, we have to store also here. So before we store here, like we will store in this vector v of num will be equal to o, like for every number I'll okay, so okay so if it is already stored, if some value is already stored, then why to again call bfs for that? So what we can do is that let's let's initialize it with int max. Okay, and if so we will only store if the operation if v of num is less, the value which is if the current operation is less than v of num, then we will store. Okay, then we'll update v of num. Okay, and also we will push this only when if uh, why to call bf so if op plus 1 means the operation for this current new num guy, this much operation is required, but if this is smaller than what is already stored in the v of n num, then only we will call this, otherwise no need to call because already we have called. Okay, okay, then only please called. Okay, yes. Why to update it here? Let's update it here itself. And let's update the v of 1 to be 0. Let's delete this, no need of this. So I think it's fine. Okay, this is how we can find the and also I wanted to find the how much operation maximum for any element. So int max mx equal to -1, say. So I will operation I will have to maximize. So mx equal to max of mx comma op. So I need this value. I just want to find how much is the maximum operation. Let me print, then I will decide whether my approach is correct or not. If this is like, obviously I have to double check it, otherwise no need of thinking, no need of proceeding with this approach. So let's give some let's give this input. No need of these all. And also Why is this error coming? No output. This has not been printed. Why? Why is this not getting printed? What is the problem? It's not getting printed. What? This call going. Why is this not getting printed? Mm. 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 What's the issue? Mm. Why is it not getting printed? Let's remove this and try. Why is it not entering this loop? What? Oh, solve is not called. Oh shit. Mhm. I am also so stupid. Okay, so let's try this. Okay, it is printing 0. Why is it printing 0? Mm, not able to understand why is this error coming. I mean, okay, num is on. Then what is the new num? Let's see what is the issue. Okay, it's fine. 2. Is it not entering this? It should definitely enter. It is entering. So then if 2 is pushed, then why is it not coming again? Why? Pretty weird. Num is becoming 0. What? One. Then this is new num. Okay. It's 2. 0. Oh. I'm such an stupid. That's fine. Okay. Okay. Got it. So, mm, if I think fine. Mm, hmm. Yes. Okay. Maximum operation will be 12. I was also thinking of around this. So definitely we can solve this using my approach. Mm, let's mm, mm, no need of this. We have already calculated. So mm, so 12 into 1000, 12,000 will be the maximum number of operations. So if we get k equal to mm, mm, I mean in 12,000 operation we can convert all the numbers maximum. Okay. So so what we can do, if k is greater than equal to greater than 12,000, what we'll do is that k is equal to 12,000. Okay, now we can easily apply the we can easily make the dp. vector of vector, okay, dp of n comma vector mm, mm, n plus 1, right? I guess this is fine. Okay, now we have initialized everything. Just one check, let's do a quick check whether our BFS is working fine. Let's print the value of v of 2. It is 1, indeed it should be 1. v of 3 should be 2, yes indeed, because yeah, and v of 4 should be, I guess, 2. Yeah, because 1 to 2, 2 to 4, 2 plus 2 by 1, yeah. And v of 8 should be 3. Yeah, working perfectly fine. So now we have to now we have to just do a simple knapsack. So let's do a recursive one. Let's call it from n minus 1th index. I have 0 based indexing, so, and in k we can call it from k. And what else we have to pass? What are there with us? Okay, we have v, we have c, we have b also, b, we have c also, and we have dp also. That's a parameter. And then here so it will return something. Int I. Oh, this is for b and this is for c, and now dp. Let's copy this. Okay, I guess this is pretty fine. And now let's yeah, so now let's make a we have two choices. Either we can select this current one or we can reject. So if we not select, sorry, then it will be this only. Okay, v C DP. And if we select, then let's initialize our answer with -1 plus, because this can't be negative, so obviously price can't be negative, so -1 will be fine. So k minus a of mm, mm, b of I. Sorry, operations of I, right? B. Okay. So suppose that we are at ith index. So we have to do certain amount of operation. Okay. So we have to subtract. Hello. Yeah. Hello, Hisanu-san. Yeah, I am awake. Yes, yes. What are you doing? Okay. I am fine. I am fine. I am fine. I have implemented one feature, the font feature. Now I am making a YouTube video, and again I will work after lunch. Easy. Well, today Vaibhav have to do a lot of work and no enjoy. But we is there for him. No problem. Yeah. Working at home is very easy. Work from home. Next week also, will you work from home? No? Okay. Mhm. Okay. So when it is strong raining, we can also work from home. Oh, oh, nice. I will also work. I will also work at home when it is when it rains strongly. Tonight. Storm. Yeah, storm. It will be very nice to watch from home. Very amazing. Yes. So hurricane will also come. Hurricane. Oh, really? Amazing. Oh, okay. Very dangerous. Don't go. Yeah. Okay. Yes. I will stay. If you. Yes. I like to stay, but Vaibhav will go to Ui home. Yes. You are working. You are working now in home. Sensei, uh, what was that glass you were wearing in the morning prayer? Morning greeting. You were wearing glass artificial effect. Oh, oh, camera. Yes. You were looking very funny and amazing. Genius. Yes. Yes. You were laughing so much today. Yes. No problem. No problem. Everything is good. I am good. You are also good. No problem. Okay, easy, easy. What will you do today? Work? Only little meeting and sleep also. No sleep. I think you will sleep. Oh, okay, okay. Okay, okay. Let's let's go for work. Yeah, let's go for lunch. Yes, yes, yes. Arigato, arigato gozaimasu. See you later. Yeah, bye bye. Sayonara. So guys, he was my mentor, and today I'm doing work from home of my company, which is in Japan. So I'm not working their work. I have already done their work, and a little work to do more, which I'll complete later. Mm, so where was yeah, so this is the thing which this item is not selected, and this is for the current item is getting selected. Okay, and we are returning the maximum, and also we will have to store this TP of. And let's initialize this with -1 dp. Where is dp? And let's, if dp of I k not equal to -1, return dp I k. And one more thing is that base case now we have to write, right? So if I goes, and if I goes less than 0, uh, means no, then obviously we'll have to return 0, because obvious, it's pretty obvious. Or k less than 0. What if it's 0, exactly 0? No operation, we don't have any operation, then no profit also. So okay. And one more thing, that here we can only call this when if k is greater than equal to, right, then we'll call this. Nice. And I think it is fine now. And when it goes 0, obviously it can't return anything. Okay, okay, let's try it. Oh, call is coming, wait, and there. Okay, fine. mm, we have to return also this thing. We have not returned this. Just a minute. We have to print out also. What is the problem here? mm, oh, max. Oh, okay, okay. Think B has not been called yet. No, it's fine, but is the answer is not 7, I guess, for this. Answer is 9. Why is it printing 7? Why is it printing 7, man? You 3 K is 4. Okay. Everything is seeming fine to me, then why is the problem? Why is not coming right? So can we just try it a bit here? That let's try to v of 2 I want just print and v of 5. V of 2 I have already seen, so v of 5 I just want to print. Okay, let's print both. Let's print both 1 and 3. V of 5 is 3. 1 to 2. 2 to 4 and 5. So it is fine, then why is... Oh, 0. If k is 0, then we are returning 0. Okay. No. If k is 0, then there is a chance. If k is 0, then we can go until we can go, keep on going. Okay, this is somewhere. Okay. Yes, this is fine, I guess. Yes. So let's where is no, it is fine. Let's submit this. Let's try with all the test cases. Oh, I'm sorry. 903167. Let's see. Yeah. So I hope this is fine. Let's. I hope. runtime error. What is the issue, man? So this we have to we are accessing some. Let's make some. I think it is looking fine. I hope this should work. Yes, finally. So I hope you enjoyed it, and I know I have bored you a lot by debugging a lot, but can't do anything. Coding is a game of debugging and making logics. So I hope you got to know about this problem. Let's wrap the video.